Hello and welcome to Unit 3 for the College Tech course, and the topic for Unit 3 is trigonometry. Some of the material is going to be a bit of review from last year, the 3M course, and some of it, actually 3/4 of it will be new material. Today our lesson, the focus is on review of necessary skills, so this is going to go back to grade 10. I'm going to move through this fairly quickly, so if you are copying the note down, please make sure you pause the video as I move from slide to slide, because I am going to move fairly quickly through it. So what's the learning goal? At the end of this, I want you to be able to use Pythagorean theorem, primary trig ratios, and a review of sine law, cosine law, and use them for the real world application. So there'll be some word problems from your grade 10 and 11 course. Okay, so some of the stuff that we need to go back to is talking about stuff like similar triangles. So with similar triangles, again, these are triangles that are the same shape, triangles that have the same shape, but are a different size. So the process in setting up similar triangles is as follows. First of all, you need to go around the triangles and you need to label them accordingly. Oops, DEF. Next is to identify similar sides. So the obtuse angle at C matches with D. So I'm going to say that that side and that side correspond, which means that the triangle has been rotated clockwise, meaning that AC and DE match up, BC and DE. Once you have that, the ratio is as follows. The sides of the triangle, I'm going to put in the numerator. They can also go in the denominator. So the large triangle, I have AB, AC, and CB. I match them up with their corresponding side that I've already identified. So EF from the smaller triangle, AC matches up with DE, and then CB would match up with ED. And from there, this is your proportion. So this is what we call a proportion. You can then break your proportion into two equations in order to solve for an unknown. So for example, you could have AB over EF equal to AC over DE, and then you would solve. All right, so you break the proportion into the two equations, or the two fractions that you have enough information to work with. Or you could do the AC over DE equals CB over DE and solve. All right, so that goes back to your grade 10 skills. So similar triangles, label the triangle, match up the corresponding sides, set them up in a proportion, and then you're able to solve. Next, I want to talk about the primary trig ratios. So your primary trig ratios, we always teach you SOHCAHTOA in your grade 10, and each of those three letters is really an acronym for us. All right, so the SO part of this tells us that sine theta, so sine of an angle, is equal to opposite over hypotenuse. CAH or CA would be cos of the angle is equal to adjacent over the hypotenuse. And finally, the TOA is tan theta equals opposite over adjacent. So those three trig ratios are our primary. I want to point out that sine theta, that theta cannot be stripped away. Sine theta is the expression, so the theta cannot be separated without doing something to the cosine or tan. Okay? And the other side is just a fraction. All right? So that tan theta will tell you a ratio of two particular sides. So I have two examples set up here below, and I want to find the missing values. So what I might do, I'm just going to move this down and give me a little bit more space. You should be fine with the space given. So the first triangle here, I find my reference angle. So this is my reference angle right here. So everything's labeled accordingly. So please remember that the longest side of the right angle triangle is your hypotenuse. The side that is opposite of your angle is the opposite side, and the last side is adjacent. So if I want to find the x value, and it doesn't matter the order here, if I want to find my x value, that means I need to use something with O in it for opposite, and I know the hypotenuse. So I need to use O and H. Looking at your primary trig ratios, or the sine function here, O and H, we're going to have to use sine. So sine theta equals O over H. Sine of 20 degrees is equal to x over 7. To solve for this, remember, get x by itself, inverse operation, multiply both sides by 7. So those 7s end up undoing each other. 7 times sine 20 equals x, and by this level, the grade 12 level, I expect that you are able to use your calculator when it comes to making calculations. All right. To solve for y then, similar process. So I'm looking for y. It's on the adjacent side, so I have to use a. The hypotenuse, h, is given, so I'm looking for a and h, and that would be a cos function there for me. It's a cos function. So cos theta is equal to a over h. So cos of 20 degrees is equal to, adjacent is y over 7. Similar process now from this point. Multiply both sides by 7 because it's an inverse function. So 7 cos 20 is my y value. Again, just using your calculator, 7 times cos 20, make sure you can do this with your calculator. You get 6.6. All right, moving on to the second example then. I need to add in the one unknown here. Put it right there. So we're looking for x and y. In order to find x, if I have a right angle triangle and I know the other two sides, I can use Pythagorean theorem. So to solve for x, we know Pythagorean theorem is a squared plus b squared equals c squared. A and b are the two shorter sides. Doesn't matter which one you choose. So if I have a as my x term, then I would have b as 6 squared, and my hypotenuse is the 9 squared. Make sure you square the numbers before you do any other operations here. Too many mistakes are made when you skip that step. Isolating for your x squared, we subtract 36 from both sides. So again, make sure that you are doing the correct process here, and then undo a square root. The inverse operation would be to take the square root. So that's going to be a little bit over, or just a little less than 7, I should say. All right. To find an angle, we have to use our primary trig ratios. I'm going to use the information that's given. So I know that this is my hypotenuse side. The 6 is on the opposite side of the angle. So I know that I'm going to be using the sine function. So sine theta equals opposite over hypotenuse. So sine theta equals 6 over 9. Now, just before, I'm going to convert this to a decimal for argument's sake here, and I'll explain why. So this is 0.6 repeated. Okay, your calculator has memorized for sine theta all the possible angles. So when you tell the calculator that I have a ratio of 0.6 or a fraction of 6/9, it runs off into its memory to look it up. So there's no calculation actually occurring. It's an algorithm. It's gone to find or look for that particular ratio. So when you plug in the inverse, and this is where you have to use second function. So on calculator type 1, you would punch in 0.666. Then you would hit your second function button, and then you would hit the sine button to get the answer. For calculator model 2, you would hit second first, and these are the ones that have the displays showing what you've punched in, sine, and then you would put the 0.666 and equals. So those are the two different types of calculators out there. So please make sure you know how to use your calculator. So when you're looking for the angle, we are using the second function. So using second function sine here, I find that it comes out to be 41.8 degrees. So very, very important that you're able to find an angle. You did this material already in the grade 10 course and the grade 11 course. So this should be somewhat familiar as you move through. All right. So I guess I started in the first part of the review.